I've just talked in detail about how the linked list and the array list are different under the covers. An array list is implemented on top of an array, but a linked list is a doubly linked list. Both implement all of lists methods, but the linked list also implements the queue and stack methods as well. When you think of a queue, you might think of standing in line. When you get in a line or a queue, you expect that you'll be processed in relationship to the first person in line. We call this a first in, first out, or FIFO data collection. If you want to remove an item, you poll the queue, getting the first element or person in the line. If you want to add an item, you offer it onto the queue, sending it to the back of the line. Single-ended queues always process elements from the start of the queue. A double-ended queue allows access to both the start and end of the queue. A linked list can be used as a double-ended queue. When you think of a stack, you can think of a vertical pile of elements, one on top of another, as we show on this slide. When you add an item, you push it onto the stack. If you want to get an item, you'll take the top item or pop it from the stack. We call this a last in, first out, or LIFO data collection. A linked list can be used as a stack as well. Let's start using this new class in some code. I've created a project called linked lists. The first thing I'll do is create a linked list variable called places to visit. Linked list of string places to visit equals new linked list, diamond operator, parentheses. Like an array list, we include the type parameter, string, in the angle brackets in the declaration, and we use the diamond operator on the right side of the assignment operator. This is one way to declare a linked list. I want to take an extra minute here to talk about lists and the var keyword. I'll comment that last line out so you can see it for comparison. I'll use the var keyword instead to set up this linked list. Var places to visit equals new linked list of type string, parentheses. What I wanted to show you here is that we can use the var keyword for typed linked lists or any typed list or collection. But when we do, we have to specify the type parameter on the right side of the assignment operator in the angle brackets. We can't just put a diamond operator there as we did on that line above. Using the diamond operator without a type in this statement doesn't give Java enough information to infer the type. So in this case, the type is an optional on the right side of the assignment. Adding records to a linked list is a lot like adding records to an array list. So let's add a few places you might want to visit in Australia. Places to visit.add Sydney. I'll call the overloaded add method with 0 and Canberra as arguments and print the linked list out. Like an array list, you can use the add method, passing it just an element which appends the element to the end of the list. I next use the overloaded method for add, which takes an index like the array list. This inserts Canberra at position 0 of the list. Running this code now, you can see confirmation that the list has Canberra first, then Sydney. Because the linked list implements methods on the deck interface, we have several other functions to add elements. I'm going to create a method called add more elements to demonstrate some of these. I'll make the return type void and add a parameter of a linked list of strings. I'll call list.add first passing Darwin and list.add last passing Hobart. Hopefully these add methods are self-explanatory. They are methods that are on the linked list class, but not on an array list. The first statement adds Darwin, inserting it at the start of the list. The next statement adds Hobart, appending it to the end of the list. Let's call the add more elements method from the main method, then print out the list. I'll pass places to visit to the method and print again. What do we get? Let's see. Confirmation that Darwin was added at the start and Hobart to the end of the list. In addition to these methods, linked list has a method called offer, which is queue language for adding an element to the end of the queue. Let's add that to the add more elements method. List.offer, passing Melbourne. Where does that place Melbourne? Let's see. You see Melbourne now at the end of this list or queue. The offer last method does the same thing as the offer method. We also have an offer first method that does what the add first method does. So let's add these next. List.offer first, passing Brisbane. List.offer last, passing Toowoomba. Running this now. You can see Brisbane as the first element and Toowoomba as the last. Continuing on, there is one more method for adding an element. If you're familiar with stack language, you might know that when you want to add something to a stack, you push it. We also have a push method. The top of the stack is the first element in the linked list, and if you're using linked list as a stack, pushing will insert the element at the start. List.push passing Alice Springs. Let's review the output. You can see that the push method placed Alice Springs at the head or beginning of the list. You can see the linked list can be used as different types of data collections: a list, a queue, a double-ended queue, and a stack. Like the many ways to add an element, there are also many ways to remove an item from a linked list. I'll put examples of these in a separate method called remove elements, the same parameter as the previous method. List.remove4, list.remove passing Brisbane. Here we're simply calling the remove methods that you see in action with the array list. The first statement removes the fifth element in the list, which will be Sydney, and the next removes Brisbane from the list. Let's add a call to the remove elements method in the main method and print the list. I will run it. And you can see confirmation that Brisbane and Sydney have been removed. The linked list has additional methods to remove elements that aren't on array list. One of these is a no argument remove method. First, I'll print out the list, then I'll remove the first element and assign it to S1 and print it. I am calling remove again, but we aren't passing any arguments to this version of the method. This method removes the first element in the list and returns the removed element. I assign that to a variable S1 and print that out. And you can see confirmation that Alice Springs was removed from the list, which was the first item in our list. Let me copy and paste those last two lines. I'll change the name of the variable to S2 and the method we call to remove first, and change the name again in the println statement. You can see confirmation that remove first is the same as calling remove, but might be a bit clearer to anyone reading our code. There's also a remove last method, so let's copy and paste those last two lines again. I'll change the variable name to S3, change the method name to remove last, and change the comment to say removes last element. I'll also fix the print line. As you see that Toowoomba, the last element, gets removed this time. Like the additional queue methods offer first and offer last for adding an element, we have the poll first and poll last methods to remove an element. Let's try this out starting with poll. String p1 equals list.poll, print p1. I'll copy those two statements and paste them, changing p1 to p2 and poll to poll first in the first statement and p1 to p2 in the println statement. I'll paste those lines again, changing p2 to p3 and poll first to poll last. I'll also change that comment to say removes last element and change p1 to p3 in the println statement. Let's see what that looks like when we run it. You can see Canberra was removed first, then Hobart, and finally Melbourne, which leaves our list empty. I'll add a couple of elements back to our list before we test one more method. Let's use the push method here, another stack method that pushes the item to the top of the stack, the start of the list. Imagine that push is pushing all the elements back in the pile or downwards in the stack. I'll add Sydney, Brisbane, and Canberra back into the list and print. I'll test the stack method for removing an element, which is the pop method. String p4 equals list.pop and print p4 out. I'll run this code now. As you can see, Canberra got removed using the pop method. Using the push methods, it was the last element in, and with pop, it was the first element out. This feels like a good place to end this video since it's getting a bit long, and I've covered most of the add and remove methods on linked list. In the next video, we'll look at additional methods to retrieve data from the linked list. I'll see you in the next video.